The power grid runs on balance, and frequency tells us if it's holding steady or slipping out of sync. Imagine the power grid as a perfectly balanced scale. At every moment, the electricity being generated must match the electricity being consumed. If someone flips on a light, or an entire city's air conditioners kick in during a heat wave, supply needs to adjust instantly. If it doesn't, the balance is thrown off, and that's a big problem for grid stability. The grid doesn't come with warning lights, but it does have a vital sign: frequency. Frequency is how often the direction of electric current changes in an alternating current or AC system, and is measured in hertz. In our last lesson, we talked about how current is the actual flow of electrons, and voltage is the pressure that pushes them through the wires. But in alternating current or AC systems, which are used in all modern grids, the current doesn't just flow in one direction. Instead, it reverses direction back and forth many times per second. In direct current or DC, the flow is steady, which means the voltage stays flat over time. In alternating current, AC, voltage swings up and down, reversing direction again and again. Voltage is shown on the vertical axis, time on the horizontal, and frequency is how many of those swings happen each second. Maintaining that frequency is essential. Let's break it down. Most of the world, including Europe, Asia, and most of Africa, runs on a 50 Hz grid. That means the current changes direction 50 times per second. In contrast, the United States, Canada, and large parts of South America use 60 Hz, so current changes direction 60 times per second. The grid may seem stable, but under the surface, it's constantly adjusting to stay in perfect sync. Grid frequency is a real-time indicator of whether electricity supply and demand are perfectly matched. When supply slightly exceeds demand, frequency goes up. When demand outpaces supply, frequency drops. Even a small deviation, like 49.8 Hz instead of 50, can signal an issue. If frequency drops too far, it can trigger automatic protections or even large-scale blackouts. That's why system operators monitor frequency every second. Their job is to keep it perfectly in sync to ensure the grid stays stable and the lights stay on. Now that we understand why balance matters, let's look at how electricity is actually generated and how that power makes its way into the grid.